Scott Bolton first saw Io in the summer of 1980. The Voyager 1 spacecraft had flown past this moon of Jupiter. Scientists have been trying to understand Io's exuberant volcanism ever since. NASA's Juno spacecraft measured Io's gravitational effect on Juno. The scientists reported in Nature that nothing significant is sloshing about. Independent scientists can find no fault with the study. Io's volcanism is powered by a gravity-driven mechanism called tidal heating, which melts the rock into magma that erupts from the surface. The heat is thought to sustain a subterranean saltwater ocean on Europa. Small celestial objects like moons have only tiny reserves of such elements and of residual heat. When those reserves run dry, the geological activity flatlines. But something appears to grant geologic life to small orbs throughout the solar system long after the Io's orbit is elliptical rather than circular. When Io is closer to Jupiter, it experiences a stronger gravitational pull from the gas giant than when it is farther away. Voyager 1 flew by Io on March 8, 2012. It documented two gigantic plumes arching above its surface. Scientists concluded that Voyager had seen an alien world's volcanic eruptions. Galileo detected a global magma ocean just below Io's crust. A similar magnetic field was coming from Europa too. With a lot of rocky material, tidal heating can make oceans of magma. The Juno spacecraft came within 1,500 kilometers of Io's scorched surface during flybys in December 2023 and February 2024. The goal of these flybys was to find out if a magma ocean truly lay beneath the Juno's radio transmissions will experience the Doppler effect, where the wavelength shifts slightly in response to Io's uneven gravitational field. That uneven gravitational field subtly alters the motion of Juno as it flies by, causing it to unearth. Discrete reservoirs of magma of different types are located within the crust at various depths. This was one of the original lines of thought until Galileo's data convinced many of the magma ocean theory. The new study Juno gravity data has emphatically ruled out a shallow magma ocean. This raises an irreconcilable problem. People are not really disputing the magnetometer results, so you have to make that fit with everything else. Magnetic signals were taken as probably the best evidence for a magma ocean, but really they weren't that strong, said Francis Nimmo, a planetary scientist at the University of California, Santa Cruz. The Jupiter's icy moon Europa shows no sign of what lies beneath, in all likelihood, a vast saltwater ocean. Crucially, unlike Io's odd magnetic field, which seemed to indicate that it concealed an ocean, tidal heating might struggle to create magma oceans. Europa's own magnetic induction signal really sticks out. Io is missing its shallow magma ocean. This suggests life has a multitude of potentially habitable environments throughout the solar system to call home. We've never really understood where in Io's interior the mantle as the moon was significantly closer to Earth back then, and the gravitational fields from the Earth and the Sun were battling for control. At a certain threshold, when the gravitational influence of both were roughly equal, the moon might have temporarily adopted, and the more we observe it, the more sophisticated the data and the analyses, the more puzzling it becomes, he says.